Hello and welcome to Maths with Jacob. This lesson will focus on tree diagrams part 2. This video continues with the concept of tree diagrams and looks at some extension work in this area. Here we have a tree diagram where we're asked to roll a die and then toss a coin. Okay, so they're the two things we're asked to do. When we roll the die, we have the chance of throwing either one of those numbers from 1 to 6. So it will land on one of those faces. After the die is rolled, then we toss the coin. I'll just do a few of these. If the die rolls a 1, the coin can have a head or a tail. So we have 1H, 1T. If we roll a 2, the coin can have a head or a tail. So we have 2H and 2T, and so on to the end. So the tree diagram to the left shows all the outcomes when a die is rolled and a coin is tossed. As a result, we can answer the following questions. So here are just two basic questions. Now, if we remember from the previous video, the important thing about the tree diagram is you have to find the sample space. That is, all the possible things that can occur. And here they are here. And when you add them up, you will have 12 possibilities. So that's really important. So there's the number of the sample space, and these are actually all the individual occurrences. Now we can answer our questions. How many possible outcomes are there? The answer is 12. Just add those up and you get 12. What is the probability of throwing an even number and a head? Even number and a head. Okay, so that's 2H, so there's one possibility. 4H is another possibility, and 6H. So they're the only three occasions where you can throw an even number and a head. So the probability of doing that is 3 over 12, which is simplified to 1 over 4. Here's another example. On entering an ice cream shop, you have a choice of 3 ice creams and 2 toppings. The above tree diagram shows all the combinations. We're going to list all the possible combinations. So here they are. So you remember, you start here on the tree diagram and you work right up to the top, and then you come back to the beginning, excuse me, and you keep continuing until you reach the bottom. So we have vanilla nuts. That's that one. Vanilla sprinkles, that one, and so on. That gives you 6 possibilities. So how many different combinations are there? 1, 2, 3, 4, 5, 6. Okay? So we have 6 combinations. If you choose a combination at random, what is the probability that you will choose an ice cream with a topping of nuts? In other words, it doesn't matter what the ice cream is, we must make sure that we have nuts in the answer. So there's one there, and there. So that's 3 occasions where we have nuts. So the probability of having a topping of nuts is 3 over 6, because there are 6 possibilities, but only 3 of them contain nuts. That can be simplified to a half. Finally, this is a very popular one for a tree diagram, one of the most popular questions you can get asked. The above tree diagram shows all the possibilities for a family of 3 children. Okay? So from the start of the tree diagram, the first child can be a boy or a girl. See, that's the first child. That's the only choice you have. If the first choice was a boy, or the first child, the second child can be a boy or a girl, but if the first child was a girl, the second child can be a boy or a girl, and so on for the third child. When you go across the tree, boy, 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 that one. Boy, boy, girl, that one. Boy, girl, boy, that one. And you go all the way through, excuse me, and you see that you have 8 different possibilities in the sample space. Now we can answer the questions. What is the probability of having 3 girls? That's the only instance where you'll have 3 girls out of 8 different possibilities. So the probability of having 3 girls was 1/8. What is the probability of having only 2 boys? Only 2 boys. Okay, well, here's one possibility. Here's another possibility. And there's the last one. So the probability of having only 2 boys is 3/8. So this video has introduced us again to the idea of tree diagrams, and we've seen some very interesting examples which allow us to find the sample space and the number of possibilities in the sample space, and then we can answer all the relevant questions.